Hi, my name is Jonah Miller. I'm a graduate student at the University of Guelph in Ontario, Canada. I study theoretical physics, including differential geometry and quantum gravity, but I'll be doing some additional things in the fall. As a theoretical physicist, I spend most of my time studying equations and programming. But if you told my high school self that this is what I would be doing for a living, I wouldn't have believed you, and if you told me I loved that work, I would have openly laughed. Well, I think that most people struggle with math and physics in high school, and I was no exception. Because of illness, I had to take pre-calculus and physics twice. Despite this, when I got to college, I decided to major in physics, mostly on the advice of my parents. It didn't go much better at first. I felt alienated in the 350-person classes, and my grades were abysmal. I even had to take the second semester of physics twice. But I hit a turning point when I took the third semester, which talked about modern physics. Topics in modern physics are special relativity, general relativity, and quantum mechanics. You can't go faster than light. But light, by the way, is both a particle and a wave. Space and time are inseparable. Oh, and they're curved. And the evidence of all this is all around us. The GPS in your phone takes into account the curvature of space-time, and the computer you're watching this on uses transistors, which take advantage of the quantum wave nature of electrons. Every Tuesday, our professor for this class would sit in the common study area and take questions. About 10 of us would gather around him, work on the homework, and whenever we got stuck, we'd ask for help. You can never get a straight answer out of our professor, though. He'd answer each question with another question. But you'd think this would be really annoying, but it was actually really exciting. With our professor's prompting, computational problem sets turned into deep, involved discussions. If a subatomic particle is a wave, what else is? Are solid objects? What about a molecule? A person? A baseball? This was the kind of thing we talked about, and it was really great fun. At the end of one of these sessions, I must have looked back and thought, if this is what physics is, I can see myself doing this the rest of my life. And through these sessions, I discovered that physics is a deeply social, raucous endeavor, and I discovered in physics an intoxicating sense of empowerment and a sublime beauty. For example, what is light? And what is color? One answer to this could be that we have rods and cones in our eyes, which let us perceive color, but a more deep answer would be that light is a wave, which has peaks and troughs, and the number of peaks and troughs determine the energy, which in turn we perceive as color. But then why do objects have colors? Why is one object red and another object green? The answer to this is because electrons are also waves, and if you want an electron to orbit a nucleus, it has to have a certain number of peaks and troughs, which determine the energy, which in turn helps determine what colors of light that atom can emit or absorb. I'm not a very religious person, but I think that the feeling I get when I ponder questions like this must be very similar to the feeling people get when they contemplate the vastness of God. So is there a lesson in my story? Well, I would say that the lesson is that even if you don't like physics and math, and even if you think that you're not good at them, you should stick at it and try and realize the beauty and the amazing strangeness of what physics and the world really is. And if you stick with it, you'll get to see some really cool things. Thanks.